Okay, so we are going to be building or writing a function rather that is going to take a list of numbers. So it takes this list of numbers 1, 2, 3, right? And it's going to return a number 1, 2, 3. So this is, for example, you are given a bunch of digits and you want to construct a number back from the digits. So to do this, we are going to use the famous folding functions in Haskell. I use a fold left and say, let me increase my font 1 minute. Yep. So we can use the folding function and say fold left accumulator value and say accumulator plus value, but like ideally this is not what we want to do, but it will give us 6, right? Because 1 plus 2 plus 3. So but we need to implement something else to concatenate these numbers. So let's start implementing this function that we need to do. So let's call the function digits join, right? And the signature is going to be it takes a list of integers and it returns an integer, right? So when we say digits join, I take, if the list is empty, then we should return a 0 then. And if the list is not empty, then we start our work, right? Digits join list. This might even not be useful, but so digit join and the list of digits. Okay, so what do? Let's fold left and do the same thing, accumulator value, and just return the accumulator for now. And the accumulator is going to be a tuple actually. It's going to be a tuple of the current, like a counter. So this will be the counter and the value. The value is also going to be 0 and the list, which is digits. So we don't even need to pass digits because digits is, yeah, we can use function composition, but we won't because then, yeah, we can do function composition. We can remove this. And now if we come here, we can say dot, and we pass, we're going to return the second value of the tuple to the output, right? So basically second in Haskell is it takes a tuple and it returns the second item in tuple, like first returns the first. So yeah, like I said, the first is our counter and the second is our value. So, and you know in numbers, 420, for example, is the same as 420 is the same as 4 times 100 time plus 2 times 10 plus 0 times 1, obviously. And that's 420. So I think this is called number positioning. You can check that on Wikipedia. Also put a Wikipedia link if I remember. So yeah, so now how do we implement that here? So since we're folding left, so that means fold is going to take our list, it's going to go through our list from right to left, right? So it's going to say 3, 2, 1. So we need to be incrementing our counter on every movement. So now that we are starting with 0, oh yes, so this is 10 raised to power 0, 10 raised to power 1, and 10 raised to power 2. So we can do the same thing here. We can destructure or we can do pattern match our tuple here and say counter and value, and let's change this view to digits just for understanding. Right. So now what we need to do is we need to return a new tuple and increment the counter. And instead of just returning the value, we need to say value plus, now this is where we do our math. All right, digits times 10 raised to the power, digits times 10 raised to the power of the counter, right? So this is basically what we need to do. So and let's export this and we can test this out. So if I do load base.hs and I do digits join 1 to 3. So now it says 3 to 1, which is obviously wrong. And I think it's because I misinterpreted, or I was wrong when I said fold left goes from left to right. So it actually goes from right to left. Yeah, yeah, it goes from right to left. So if we do fold right is going to go from, yeah, so fold left goes from left to right rather. Sorry about that. And fold right goes from right to left. So fold right begins from the right. So instead of fold left, we make this fold right, and instead of the accumulator over here, the digit comes first. So we can change this. And if we reload and call the function again, yeah, we get 1 to 3. So if we do digits join 420, we should get 420. And boom. So that's how you do that. Cheers. Bye.